Here we go. Just give me a sec. This thing is loading. Here we go. All right, guys. So, right. So, any questions about what I said? Hypothesis. Let me get this. Let me see. No, I have to. Let me get this pin. All right. Here we go. So, hypothesis. We're gonna say that it is a strong all right, so it's an all right. So it's a strong opinion based on your knowledge. All right, that's it. That's a strong opinion here. So, and notice I said strong opinion because when you're strong, when your opinion strong, like nobody can convince you say another that, you know. So as we say, if you believe, for example, a lot of people believe say, well, China made the vaccine, or no, China made the coronavirus, and no matter what you talk to them, say you can't tell them nothing else, right? So that's your strong opinion. Notice that it has not been proven, it has not been tested, so therefore it's just an opinion. It's not fact. All right. So when you have a hypothesis in an experiment, what you're trying to do here is you're telling the person the opinion that you have, the strong opinion that you have, and the rest of it now is to show them how you're going to prove that your opinion is the right one. All right. That is what you're doing. All right. So basically with this experiment now, it is a lot simpler than what it look like. All you need to know is what is sodium chloride, what ammonium chloride is, and what is sun. And in the last class, I remember showing you what each of them look like. And I was saying, because you know what each of them look like, and you know how it's going to behave under certain situation, then you use that now to separate it. All right. So this is like how persons treat people in real life. You have three friends, you know, partying together, you know, and maybe your parents saying that it's bad company. So or let us say it's a school and you form a gang with three persons. And then the principal might just say, well, you know what, this gang is causing not a problem. We need to find a way to separate them. He wants to still keep you guys, keep those three persons in school so that they can probably get something out of it. But he's gonna have to separate them. And what is he gonna use to separate them? If he tells them, well, okay, you know, you should not be seen together, all right? That's one way. But then what about phone? Them texting each other and so on, and meeting after school and meeting on weekends. So again, he wouldn't. So you'd have to find creative ways to separate those persons in order for them not to be a bad gang, or at least influence the school. So I hope you're understanding what is happening here. It's the same thing. Three substances with different behavior coming together to form a powder that you are asked to separate. All right. So you are in control here, guys. The first thing we say that ammonium chloride is a white powder, and when you heat it, it sublimes. All right. So remember now, this is what we say now, because you know this could be your first. So after you you choose one of these, because when you know each of these, you know say ammonium chloride are going to separate, right, with heating. We know say sodium chloride can dissolve in water, but we know say sun will not dissolve. All right. So we write that down one side, put it down. We don't ready for it right now. We're going to go back to what the rest of the lab is saying. All right. So our strong opinion is one of these four things, guys. The first thing you're gonna do is choose one of them. All right. So and if you read and understand properly, you're going to realize that all four of them are saying the same thing. But the only reason I gave you four of these is so that basically nobody has the same thing. So I expect like if Ariana chooses one, then somebody is going to choose two, another person choose three, another person. But you're going to end up doing the same thing. Everybody get that?
Yes, sir.
Yes, sir.
So basically, no matter which one you choose, I can go through the lab and you guys can have the same thing afterwards. But when the examiner when the moderator come to mark it over your lab now and see that you have a different hypothesis from let's say Ariana has a different hypothesis from Kimberly, then we can say, well, look at that. They did two different labs. They have different hypotheses. But yet we make the work easy. Just do it one time. Everybody have similar thing and then have different hypotheses. Make it look like a different lab, different student, everything. So you won't get marked down. So that's the situation here. All right. So that's a creative way to get everybody doing this lab. And remember, guys, we have three of these type of labs to do. So it means that if we have planning and design labs to do, we can do them online. Provided that this one is successful. We have two more to do. And then that would carry your number to 8, which is the minimum required this year. However, we don't want to go for the minimum. We're going to try and do at least maybe 3 more after that, and then we'll call it quits. All right. So that's the plan. All right. So let's go back to this one. We're choosing one. So let's say so Ariane, you decided which one you wanted?
Yes, sir. From last class, I wanted to choose one.
Okay. So let's say Ariana chooses one. All right. So we have Ariana here. All right. Rachel, Sashay, Kimberly. Yes. Um yeah, we have another.
I'll choose 3.
All right. So all right. So Kimberly is choosing 3. So Rachel, drop off. All right. Sashay, which one are you going with?
Two, sir.
All right, let me choose one. All right. You're going to distillation there. All right, no problems. It's you can work around that. All right. So all right. So this ensures all right, which means that let's work with this then. So you're choosing one. All right. So usually know you see in the other labs now when I will not give you the hypothesis like this. What's gonna happen is that you're going to have to come up with your own. And you get 1 mark for it. Usually you get a mark for coming up with your own hypothesis. But for this one, because you have options here, well, you can't get a mark for it. So um although when I'm marking the lab, I could probably tweak it to make it look like that. Well, you came up with it your own. So but anyway, just make sure you choose one and work with it still. All right, so typically it's 1 mark for the hypothesis. All right. All right, so all right, you wanna go so far then? Choosing one hypothesis, 1 mark. Move on. What's the next thing?
Aim.
Aim. All right, so the aim. And you should know what an aim is. No, this time you're coming up with your own aim. No, and normally I would tell you the aim of most labs. But this one, no, you're getting marked for coming up with your own aim. All right, so your aim now must be related to your hypothesis. All right, must be related to it. So let's see now. So in your case now, Ariana, what would your aim sound like? All right, your aim is a more confident version of your opinion, of your hypothesis. All right. So you're actually gonna do something now. That's where you're going to do something. Literally, you're getting physical here. All right. So hypothesis is just a little talk, people run up their mouth. And then aim now is like you step to it now. So if you're saying that in your case, Ariana, a mixture of sodium chloride, ammonium chloride, and sand can be separated using these three methods, then what would your aim be? All right. Remember now, it's gonna sound like the hypothesis, but maybe two additional words might be in there to make it stronger. All right. So your aim now, Ariana, would read something like to to separate a mixture of all right. So and then yeah, this could have write another way. But to separate a mixture of, and I'm just going to put formulas here, make it easier. I don't have to write out that long word. And ammonium chloride has the formula NH4Cl. And of course, what we have here now, sand. So we could write sand as well. Sand is really, I think sand is a mixture of three.
Sir, there's a formula for sand.
There's a formula for some sands, and not all sands are the same. So usually it's silicon dioxide, which is SiO2. However, that depends on the type of sand because there will be other things in the sand. All right. Remember, you have white sand and you have black sand, right?
Yes,
So,
sir.
yeah, so chemically they are different. So therefore, because we didn't specify which sand, I can't give you a formula. But generally speaking, SiO2 is a formula for most sand, especially the dark gray one. All right. So let's just call it sand. If it's white though, if white sand, no, white sand is made from what, coral polyps. So that's pretty much some calcium in there as well. So it's very tricky to write a formula. So we're just going to put sand there. All right. So to separate a mixture of sodium chloride and ammonium chloride and sand, probably should use the conjunction after this here. So let me go back to this thing is not writing. All right. Oh, it's off. All right. All right. So a mixture of NaCl, NH4Cl, and sand. Right. And again, we could stop here. Yeah, we could. But just trying to be thorough here, going to actually write through everything that's it, using sublimation, all of the thing here. So you see, it's not much difference here. Just put to separate. So you're saying here a mixture of this can be separated using sublimation, filtration, and crystallization. Okay. All right, Rachel is on 9. Let me just say other. All right, filtration and what's that one? Crystallization. That's one mark there. Now, what did I do? What's the difference between the hypothesis and the aim? All right. Oh, Rachel.
Sir, you practically just kind of reorganize the words.
Yeah,
That's all.
that's all. That's it. But to separate there, so I put a yeah, basically reorganize the words. That's good. So that's all they're doing, guys. The plan and design lab is easy to get the marks. They're marked out of 10 or 20. It's easy to get those. You write a strong opinion, right? That is chemistry related specifically to the things in the lab. Rearrange the words to get the aim. That's 2 marks out of 10. Easy as that. All right. And then your materials you're going to use now is, the second nature here because if you're going to separate it and you already tell me how you're going to separate it generally, sublimation, filtration, all you're going to do here is list the materials that you're going to use for the sublimation and the filtration and for the crystallization. All right. So that's it. So now, usually, in some labs, this value is 1 or 2 marks. So I think if it's mark over 10, material is going to value 1 mark. And it's going to be, it has to be relevant to what you're doing here. All right. So what you could do for this one now, so your materials here, and let me just make this for Ariana as an example here, because let me see something. If Sashi is doing this one, your own would be the same thing, except that you're going to add distillation in yours. Kimberly would have the same thing. So you guys can all run with this one. All right, all three you can get the same thing, except that for Sashi. All right, I'm saying this again. Please add distillation to your aim. All right, so this is cool. So this can work for everybody. All right, let's get that out. All right, any questions so far, guys?
No, sir.
No, sir.
All right, good. So the apparatus now is a physical equipment you're gonna use. Now let's see how sublimation will take place here, and we can get creative here. I'm gonna use pictures to show you what's happening here. So all right, so basically, and I believe, and then the beauty is that now you can actually type your labs in. I mean, you really don't need a lab book. So I know a person are telling me that, well, I have them lab book, or them lab book is where it shouldn't be or where it's not. But the beauty is that now you can type your labs. Uh these are modern times. All right. So all right, so let me see. All right, so in a sec, I'm gonna show you the setup for that one. There are many ways you can do it. So there you go. I like this image. Let's just bring this on the screen here. So guys, I'm gonna show you this image. What is in this?
Yes, sir.
All right, look at that. You see, this is the sublimation here, and this is the perfect because we're actually using ammonium chloride. And oh, they have salt here. Interesting. So it's like the same level I'm talking about them doing here, except that the sand would be in this mixture. All right. So basically, if I apparatus, and personally, I would say you could do it. You could do it in well, how I like to do it is because I'm imagining how I'm gonna carry it out. I usually draw the diagram and then list the apparatus afterwards from the diagram. So this is a good way to do it. You could even type it in Google Images, and then you see, just type in how to do sublimation in the lab, and you see this one of these pictures come up. But anyway, so all of what you see here, you're going to put that in your apparatus. That's all. That's all they're gonna do, guys. Everything.
Excuse me, sir. If we're
Yes.
typing the lab, what should we use? Times New Roman 12 and double space or anything?
Okay, so you wanna really get technical on me there. All right. Well, why not? Yeah, use that. Um, use that. Just make the font read. Just make the font readable, and
Okay, sir.
and it's not just Times New Roman that is readable as well. Think Calibri and Arial can use as well. But just use there Times New Roman double space. If that's what you're doing for the other subjects, then yeah, do it for chemistry. I have no problem there. All right. No, this is one version. Maybe this is a lot. But there's a simple one here. Let's copy this and show you what it looks like. All right, this is a simpler one. So any one of them you want to use, but I hope everybody's seen this. And so that's it. So all of what you see here, you're going to write it here. So this one is simpler. So let's go with this one. Evaporating dish. Both diagrams have evaporating dish. But then this one is more detailed because well, you get the source of heat here. All right, so we're going to start labeling. This is going to have a lot of apparatus though, guys. So first thing we can start list the ones we're going to use for sublimation. Any question? Yeah. So yeah. Definitely for the heat, you're going to use what we call a Bunsen burner. Or you can use even a hot plate. A hot plate can use, you know. Let's say when a Bunsen burner or hot plate. All right. So everything you're doing for sublimation is there. And let's go here. And you can even just go simply here. And it's gonna be glass funnel evaporating dish. That's it. Yeah, that's it, you know. Glass funnel evaporating dish. Right? And
Sir, that's different from a petri dish, or it's the same thing?
oh, good question. So no, petri dish is actually different. Um,
Oh.
yeah, the petri dish. As the name suggests, petri means dead. Basically, are hard. It's the evaporating dish has more. It's more curvy. It have more curve, right? Yeah, and why it has more curve? The curvature of the evaporating dish is different because it's gonna give maximum area for evaporation. So that's why the evaporating dish has to be curved, all right, to cause more of it things to evaporate. So and then the petri dish now is a lot more flatter. All right, so that's the idea there. All right, so that's basically it, you know, guys, for the sublimation stuff here. Uh, the filtration is filtration. Now we can do that. Filtration easy. You did that lab, and it's that's why I'm sure you know why it's important to do labs in order because you did filtration, you did sublimation, you have an idea of what it is, so we can do this one. And then when they tell us to do labs by the end of February, then you have a problem because you didn't do the labs in the right order, so the knowledge is not there to do them properly. But that's the idea here. But then all right, so filtration now, guys. Let me just get this up on the screen. Filtration lab is going to even be it's going to be more it's going to even be more simple because all you need is just a filter paper and a funnel to do it. Okay, let's admit okay there. No, I'm trying to find, but then you have more. You can't know. Let's write them down. Yeah, you have more. So like if you were doing filtration at a university, though, it would be like a more technical. But at high school, you kind of get away with a lot of stuff here. So let's look at the filtration. All right, everybody seeing this?
Yes, sir.
All right. So basically, you're just going right here. You just have your funnel, as you can see. Some labs have this type of shape funnel, and then funnel filter paper here, and that's what you're going to add here. Funnel and filter paper. You have your you don't you really all right. So let's say you're going to add this one. This is your what you call this flask, the conical flask. You could even write beaker. So beaker or flask. You could use beaker or flask. So these now you can add them. Yeah, and I'm not copying. All right. So you're going to add these as well. So that's all you're going to do. So go through that list and add the stuff. So I give you the sublimation, what you need for sublimation, what you need for filtration, what you need for crystallization now is the next thing, which I think that was done last class as well. For crystallization, all you need is the evaporating dish. And you already have that already. Well, I think you're supposed to have that. Let me see. Yeah, evaporating dish. So therefore, you just add your funnel filter paper. And that's it. Funnel filter paper. What else? Well, whatever. Beaker or flask. And notice I say beaker or flask, so you just choose one. So I don't want to write or in your own. You just choose the one that you're going with and leave it. All right. So any questions here?
No, sir.
No, sir.
All right. So basically we're going to start with 9:20 now. So you might have another class, but reagents is just the chemicals that you're going to use in the lab, guys. Which is powder mixture and water. So far, we're not adding any reagents, is any chemical you use. So, and these are the only two. So, you get 1 mark for apparatus and materials here. If
Sir,
it's
we wouldn't add the sodium chloride and the ammonium chloride that we use.
well, the white powder mixture, it covers that.
Oh,
You
okay.
see that? Yeah. So you're going to write your NaCl that because you know what is in there already. This is your ammonium chloride, NH4Cl, and you also have your sand. So that's the white powder mix. If you want to write it out like that, fine. But you could just write powder mixture there. The diagram is shown. So these would be a diagram. So you're basically going to take one of them. Take like one of them. Let's see, copy that. For the diagram part, it's just simple. Just get the diagram. Again, these are modern times, so you can angle your hand with the with Microsoft Word or whatever and get these done quickly. All right. All right. So and then this is it. So I have just actually shown you then how to get this diagram here. So we're going to use this as for your sublimation. That's your first one. All right. I think for Sasha no, because she chose distillation or the one with distillation, you're going to need another setup for your own. Yeah, this is going to show that. All right. We didn't do that, lab. All right. We didn't do that, lab, but then distillation setup is easy here because all you're going to do is do this then. All right. Let me just show you this quickly. All right here. All right, so this is distillation, guys. So basically, you know, we can't even cut a long story short here for your own sachet. What you're going to add to your own, and this is for sachet only, is your distillation apparatus. Just write that. You're still going to get your marks because you already write out these already. All right, distillation apparatus, and this is for sachet only. All right, so just cover that. All right, so we have these. We have a filtration, and we crystallization thing. All right, so again, you guys can finish this, and then the method now is just like the steps that you're going to take to do each of them. So you're going to write the steps of sublimation. So your method would be, all right, let me just come off of this. Your method now would just be this. It'll just be how you're going to do the sublimation. All right. When I put the other one there, how you're going to do the filtration, how you're going to do the crystallization. That's it. All right. So any questions here?
No, sir.
Sir,
Yes.
must have 3 diagram.
Yeah. 3 diagrams. 3 diagrams. All right. So 3 diagrams going with here. So I show you how that the sublimation one. And I think where is the can't find the filtration one, but you're basically going have 3 diagrams here. All right, so that's that. So the method now value 2 to 3 marks. So that's where you want to make sure you have something there. So just you can research those, how you do sublimation, how you do filtration, and then how you do crystallization, put them in a method in sentences, and you form a method. That's 2 to 3 marks, which already it's most of the marks here. So you have some lines here for the methods here. And then afterwards we talk about the variable now. This is the part that gives students trouble. But then you're getting I think you're getting what 2 to 3 marks for this part. So most of the points for the labs come from your variables and your method. And what we mean by variable is it's like what you're going to change throughout the lab. And then I think this have missed out a word here. All right. So what you're going to change throughout the lab. So for example, control variable would be what's not going to change. So like a constant, like what's not going to change. You're going to still use you're still going to use what you could say the method use of
Sir, what about the sand?
the sand. What about the sand?
Sir, because the sand doesn't change.
Sand, all right, but yeah, all right, fine. So yes, so you would say your control variable would be the mixture. Then let's put it that way. It's not the sand you're going to use, right? It's the mixture. So let's use that as the control. The mixture.
Sir, but how can you use that, sir, if you're going to change some other things? Because remember, after we finish the lab, then some of the things are going to, like, for instance, the ammonium chloride would be gas.
All right, very good. All right, so I'm glad you mentioned that. So then, how is it going to change? That's the question. What are you going to do to change it? And what is going to change too? You just answer these last 2 questions, Ariana. The responding variable is the sublimate. That's after you go through the sublimation. All right, the manipulated variable is the well, it's actually a sublimation. So you just answer the question there. Sublimation is the independent variable. It's the one that you are manipulating, the one that you are going to adjust. You are in control of that one. All right, but you what you're doing now will affect what will happen, which is the responding variable. So this is how the mixture will respond. So the mixture is the control, right? The independent variable, what you are doing to will adjust this mixture. All right. So sublimation is that one. Then afterwards, you're going to what? Filtration and then crystallization. These are manipulated variables. You are doing these. And so what I'm saying now, Ari?
Yes, sir.
All right. What's going to respond? The filtrate and residue will come from the filtration. And from the crystallite, you have the crystallite. Never hear them use the word crystallite, but they say the crystallized salt. That's it. That's it. Control variable here. Use of distilled water as well. Is it when you actually need water to do the filtration? So distilled water. All right. And that's it. We could even break down the independent variable into like heat and those things as well. But I mean, I'm just making it simple here for you guys. These are the variables. That's 3 marks you're looking at there. Any questions? So
No, sir.
yeah, so I'm not helping now because 3 marks is enough. You when I do the method, that's probably 2 to 3 marks there. So that's 3. And if I'm marking this lab out of 10, so that the variables is 3, method is let's say 2, that's 5. Diagram here, you get 1 mark for it. Reagents, that's 1 mark along with the apparatus. So That's so much. So it's 3 and 2, 5 and 6, 7. EM is 1, hypothesis 1. That's 9. All right. Now something is missing, and that's where when it come we're going probably discuss that next class. But the up to there, because after you do this variable here, I gave you some theory just for you to read what these are. But we're gonna get the other marks from now is the expected results, which I actually gave it to you. So you can put it in, and the limitations as well is one. So this is it. This is it for you guys. See, I've guided you to getting almost full marks in your first plan and design lab. All right. So what's gonna happen is that I think I uploaded it as an assignment in the classroom, and then of course if you have any questions, you text or you communicate in the group. All right, but I'm gonna make this video available as well, video of this class, so you can go back over it and you know, of course if you're not getting me or if you can't bother to ask, whichever way. All right, so that's it, guys. Thanks for coming out to class, and please do this lab because I set the deadline for Friday. So do it before then so that I can at least mark it and get a grade for you.
Okay, bye, sir.
All right,
Okay,
Kimberly.
sir.
All right.
Bye, sir.
Yeah, bye.